Last section here in Chapter 7, we're constructing our confidence intervals for variance and standard deviation. As soon as we see this is a dead giveaway that we are using tables. Let's try this again. A completely different table, or table G, which is called a chi-square distribution. Take a quick look at our chi-square distribution table. It's table G. So table G is right here. You can see the chi-square distribution label right up here, table G. Much like our t-distribution, our chi-square distribution is based on degrees of freedom. Our degrees of freedom here are simply our sample size -1, so that should be pretty easy to come up with. Here we do have several columns here at the top, and basically separated from right here. Our smaller decimals on this side and our larger decimals on this side, which is what we'll look at right now. Those are the alphas, or the area and the tails of the curve. So here we're using two different chi-square values from the table. We're using one that is our desired interval subtracted from 1. So if I want a 95%, I subtract 95 from 1 and get 0.05. So that again is our alpha. That's the area and the tails of the curve together, both tails together. We want to take that number and divide it by 2. So 0.025 is one of the columns we'll use at the top of that table. It's the area in one side of our curve. And the other column we'll use is 1.05 divided by 2, or 1 minus alpha divided by 2, or in this case 0.975. So these are the two columns that we would go to along with our degrees of freedom to find our chi-square scores right and left. Now notice the right and left here. The right simply means that that number comes off the right side of the table, so one of these 5 numbers, 0.01 or 0.10, 0.05, 0.025, 0.01, and 0.005, and then back over here, our left side comes from the left side of the table, or one of these 5 columns right here, working backwards, 0.9, 0.95, and so on. Okay, so those numbers are going to come from the right side of the table or the left-hand side of the table, not based on the right or left-hand side of this formula, but based on where they come off of the table. Okay, so we have a little bit of setup work here to do. We have to find our columns. These is the process to find the columns to use at the top of the table. And then we use that along with our degrees of freedom to find these critical values. Going backwards here, n is our sample size, s squared, that's our symbol for sample variance. Hopefully we recall that from chapter 3, but s squared is our sample variance. Other than that, the formula itself should be pretty straightforward, just knowing that we're using a different table and how to use that table. So let's look at our example here. Find the 90% confidence interval for a population variance if a sample of 28 had a variance of 116. So our sample size, or n, is here. Our sample variance, or s squared, is 116. We have to do our legwork here for 90%. So I'm going to take 1 minus 0.9 and get 0.1. I'm going to take 0.1 and divide it by 2. That gets me 0.05. There's my right-hand column. And 1 minus that number, 1 minus 0.05, is 0.95. There is my left-hand column. So I'm going to set up here. I have my sample size -1 times my variance, construct an interval for the population variance. And now I'm going to go to my table and look up my right and left hand side. I'm also going to mark on here that I have 27 degrees of freedom. My sample size was 28, so 28 minus 1 is 27. So using the 0.05 column, 0.05, I'm going down to 27 degrees of freedom. 0.05 down to 27, and we find 40.113 for our right hand side. 40.113. I'm going to go back to the table and use the 0.95 column with 27 degrees of freedom, and we get 18.114. Okay, so there's our numbers pulled off of Table G. Table G because we had our standard deviation and variance we were working with. If we make our calculation on the left-hand side, I get 78.08. And on the right-hand side, we get 172.90. So there's our confidence interval for 90%. Based on that, again, marking the fact, I could have marked this begin with Table G because of our working with population variance. One other side note here is if we want the standard deviation, we would simply take the square root of both sides, so 78.08 square root for the variance and the square root of 172.90. And let's just do that real quick. So over here, I'm going to have to rewrite it on this side. 13.15, and the square root of 78.08 is about 8.84. So our variance is here. Our standard deviation is here. It only told us to find the one for the variance, but I wanted to go ahead and show how we come up with a standard deviation as well. We probably should know that from our work in Chapter 3 moving forward, but just in case, there it is. Okay, again, find the 99% confidence interval for the population variance. Population variance, Table G, or our chi-square score. If a sample of 19 had a variance of 83. So there's our variance, or S squared, and there's our sample size, or our N. So we have 19 minus 1 times 83 over a number for our variance, 19 minus 1 times 83 for a number. And over here to the side, we'll find out what columns to use. So 1 minus 0.99 is 0.01. We take the 0.01 and divide it by 2. And there's 0.005. There's our right-hand side. And 1 minus 0.005 is 0.995. There's our left-hand side. For our sample size is 19, we have 18 degrees of freedom. So we'll go to our table, 18 degrees of freedom, and 0.005 is 37.156. 37.156. And back to here for 0.995, 6.265. And we make those calculations, and we will get 40.21 and 238.47. 238.47 for our variance. And again, if we want our standard deviation, we would take the square root of each number, and that would change our symbol there. This one just said the variance, so I'm just going to stop there this time. One more time, just to make sure we're all on board here. Oops. Find the 95% confidence interval for the variance and standard deviation of the nicotine content in cigarettes manufactured with a sample of 20 has a standard deviation of 1.6. So noting here, standard deviation, that is our S, we're finding our interval for variance and standard deviation, so both of them this time. And our sample size is 20. We're going to work with that. Let's do our columns here first. So I'll do 1 minus 0.95 to get us 0.05. 0.05 divided by 2 gets me 0.025. There's my right-hand side. And 1 minus 0.025 is 0.975. There's our left-hand column. From there, our sample size is 20. 20 minus 1. Note that the 1.6 is a standard deviation, so to make it the variance, we have to square it. Calculate our variance first. So 20 minus 1 times 1.6 squared. Degrees of freedom back over here. our 19, our sample size is 20, so our degrees of freedom are 19. We'll go to our table, 19, we use 0.025 first, so 0.025 down to 19, and I get 32.852. That number will go in here, 32.852. We'll go back to our table, 19 and 0.975 gets me 8.907. 8.907 is the number that goes here, and we'll make our calculation. If we plug that in, we'll get 1.48 and 5.46 for our variance. If we take the square root of each of those, will give us 1.22 and 2.34, and that will be our confidence interval for the standard deviation. So we have an interval for each one. The variance here, you can see the symbol is population variance, and here's our population standard deviation. There's our two confidence intervals.